Well, howdy there, Internet students. It's Mr. Hermanson again. Hey, we're starting Chapter 6. Make sure you get that packet or print out the pages you need, or get your math notebook if you can't print it. This chapter is geometry. We're going to learn about transformations and symmetry. In this first lesson, we're going to learn about what it takes to translate or move on a coordinate grid. So move to this page. Just a couple of things you might need to try and remember from past is a coordinate grid is a place where you put dots. It's a plane formed by two number lines, an x and a y axis. If you forget which is x and which is y, look at the picture here. The origin is the point 0, 0. And it's where you start always. The quadrants are the four regions that are separated by the x and y axis. Notice how they work. 1 is here, 2 is here, then 3, and then 4. The x-axis is the horizontal number line, and the y-axis is the vertical number line. Now, to graph a point, the first number represents the x-axis, the second number represents the y-axis. So just a quick review on that. Let's say we want to do the point -3, 5. So we would first go to -3 on the x-axis. So we call the point xy coordinate. -3 on the x-axis is right. Let me draw a little arrow there. -3 on the x-axis is right there. And then -3 on the y-axis, or 5 on the y-axis is right there. So where those two lines come together, right there is our point. And I'll just put a dot there. So that's the point -3, 5. So make sure you go on the x-axis first and then the y-axis when you're plotting those. All right. Okay. We're going to talk about translations and dilations. A transformation is a change of size, position, or orientation of an object. And there are 4 different types. There's dilations, translations, reflections, and rotations. A dilation is when you change the size of a figure. If you've ever been to an eye doctor and had your eyes dilated, you notice that your pupils change size. Translations are where you slide something around to a new position, so up, down, left, right. Reflections are when you flip the object over a line of symmetry. And rotations are where you spin it around. All right, so those are the 4 ways you can move an object on a coordinate grid. You can make it bigger or smaller. You can slide it around. You can flip it. And you can turn it. All right. So in later lessons, you will be introduced to Mugwump, who is a computer-generated character. And here's the hat that Mug wears. We're going to write down the coordinates for Mug's hat. And I've done the first couple for you here. Point A is 1, 1. That's right. Let me make this red. That's right there. And we're going to go around, and then we're going to end up at the same place. Okay? And so the next point B is 9, 1. Remember to put the x-axis first. Go ahead and fill in the rest of those points. All right, now we're going to change the hats, and we're going to draw the new hat. So the first thing we're going to do is we're going to add 2, and we want to kind of analyze what we notice about the changes on the graph when we do this. So this first one here, we're going to add 2 to the x and add 3 to the y. So 1 plus 2 is 3, 1 plus 3 is 4, 9 plus 2 is 11, 1 plus 3 is 4, 6 plus 2 is 8, 2 plus 3 is 5. Go ahead and finish writing in those. Now that we have those, what we're going to do is we're going to graph those points on your graph. So I'm going to actually make a snip of these points and then move it to the next page and paste that so I can go along with you here. So this is the original hat right here. My new hat is at the point 11,4, which would be right there. Point A is at, I skipped a point there, sorry about that, 3,4. It's right there. That's point A, the new point A. Sometimes we call that the image of A, so we put a little mark here to mean image, A image. Then B is 11,4, the image of B. The image of C is 8,5. The image of D is 8,6. The image of E is 6,6. The image of F is 6,5. And the image of G is back to the beginning again at 3,4. So if I draw this now, and do a nice straight line, I'm looking at it like the hat looks pretty much the same. In fact, almost exactly the same. It just moved into a different position. We call that a translation. And you can see that every point has moved to the right 2. And has moved up 3. All right, let's go back to the other page. And you guys are going to follow the rules and write the new points. So we're going to do subtract 1 from the x here. 9 minus 1 is 8, and we're going to add 4 to the y. 1 plus 4, now this is the original, so we're doing it to this point, to these original points. Okay. On this next at 3, I'll just do the first couple points with you. We're going to add 2 to the x, the original x, so 1 plus 2 is 3, and we're going to 3 times the y. In algebra, we don't put the time symbol in there because it gets kind of confusing. When you put a 3 in front of the y, that means 3 times y, so we're going to do 3 times 1, which is 3. On this one, it's saying take 1/2 times x, so half of x is, half times 1 is 0.5, and then half times y is another 0.5. Each coordinate is half of what it was. And then in the last one, we're going to double x, so 2 times 1 is 2, and we're going to triple y. Let's go through those one more time so you make sure you got those. We are going to add 2 to the x, so we're going back to my original x here is 9, so add 2 to that, that's 11. And we're going to multiply the y by 3. 3 times 1 is 3. This next one, we have to take half of each coordinate, multiply both. Basically, it's 50% of the numbers. So half of 9 is 4.5. And half of 1 is 1/2. And in the last one, we're going to double x. So 2 times 9 is 18. And we're going to triple y. 1 times 3 is 3. All right, you go ahead and fill in the rest. Check back, make sure you got them all right. All right, check your work there. And then you're going to go ahead and draw all these new hats on the grids on the next page. And we're going to talk about what happens to them. All right, so here's what my hats look like. Like I said before, that looks like the first hat is pretty much the same size. It just seems to be moved to a different spot. Hat 2, same thing. Same size, just moved to a different spot. Hat 3 definitely changed in size. It didn't get any wider, but it got taller. So think about that. Hat 4 got a lot smaller. Hat 5 got both wider and taller. All right, so let's answer these questions. When you write a rule for translating, for changing the hat, you use the coordinates x, y, and then you say what you're going to do to those coordinates. On the first one, we added 2, then we added 3. And that we found out that that hat moved to the right 2 places, or 2 units to the right, and it moved 3 units up. So go ahead and answer as many of these questions as you can, and you can check back and see what my answers say. But go back and look at the hats to help you figure that out. Okay, to translate, move it to the right, you want to add to the x. To move it up, you want to add to the y. Hat 2, subtracting from the x coordinate moves it left. Subtracting from the y coordinate would move it down. Multiplying by 0.5 made it shrink. The number we multiply the x and y coordinates by is called the scale factor. If we want to triple the length and the height, we would multiply both them by 3. The ones that are not similar, that means they don't have the same shape as the original hat, are hat 3 and hat 5, and the reason is because they have different scale factors. If you wanted to move it 2 units up, but have the x coordinates say in the same spot, you would just, in other words, not move it left or right, just up, you would just add 2 to the y coordinate. If you wanted to make it grow, you need to multiply by a number greater than 1. So notice I multiplied by 2, that would double the lengths. If you want it to grow, you want it to be 5 times as wide but stay the same height, you would multiply x by 5 and leave a y the same. Would that hat be similar? No, because you have different scales. You need to have the same scale on both the x and y coordinate for it to be similar. If you want the lengths to be 1/3, you could just multiply by 1/3, or you could divide by 3. Either way works. If you wanted segments to be twice as long as Mug's hat and moved 8 units to the right, twice as long, multiply both x and y by 2. And to move 8 units right, you would add 8 to the x coordinate, not the y coordinate. Go ahead and summarize your findings here, like what makes it move up, what makes it move down, what makes it get wider, what makes it get taller, things like that. And when you're comfortable that you can figure out what's going on, go ahead and work on your homework. All right, we'll talk more about this during our meeting, and if you have questions, let me know then. Good luck.